All right, it is day 3, so let's just get into it today. We're still with that elf. Gondola lift will take us to the water source. Gondolas aren't moving. We offer to help to fix the lift. If we add up all the part numbers, it should be easy to work out which part is missing. The schematic consists of a visual representation of the engine, lots of numbers and symbols. Any number adjacent to a symbol, even diagonally, is part number and should be included in your sum. Periods do not count as a symbol. In the schematic, 2 numbers are not part numbers because they are not adjacent to a symbol. So that's 114 up here and 58 right here. Everything else is adjacent to a symbol. Of course, the actual engine is much larger. What is the sum of all the part numbers in the engine schematic? So let's grab this and we'll set up our test. We've got just create day 3. We've got part 1. We've got this input. Let's get rid of this and return some string that will fail our test. And then we need to get the answer here. So if they're not adjacent, then we don't count them. Everything else is a part number and we sum those. So that's the number we need. And we need to sum part numbers. Okay, we'll just work day 3, part 1. We've got a failing test here, so we're good. So I think what I want to do is I want to go really sort of introductory here. I'm going to split everything effectively. So I'm going to do input.lines because we're going to split this up into a bunch of lines, and then we're going to split it up into horizontals. We're going to get a position in a grid for everything. So we'll enumerate here so we get the IDs. We want to map over that. That is going to give us the index and the line as a tuple. And this is just building up our, I'm going to use a hash map, I think, here. So input lines, enumerate, that gives us the index. We map, we get the index to line. We have to take the line, we have to iterate over it. We want to enumerate here because we also want the index here. So this is the X index, that's the Y index. So this is the X index, and this will be a character. Actually, this isn't iter, this is cars. I don't know why I typed iter. So now we're getting every character with the X position. We're going to change I to Y. So we've got Y and X. Both start at 0, 0 in the top left corner. And I think we're going to set this up as XY as a tuple. And I'm going to put an underscore here. We need to figure out what we're going to have character be. I guess character can be an enum. This would be pretty, right? We could have, let's see, I'm going to just call this value for no real reason. And it'll either be a symbol, it'll be a empty, or it will be a number, right? And then here we will match on character. And if it's dot, it's going to be empty. If it is some character, right? If it's an ASCII digit, then we 2-digit, and this will be value number. And if it's anything else, we're going to call this a symbol like that. This needs to be a character. So importantly, characters in Rust are written with single quotes, not double quotes. Call expression requires function. That is because we didn't set up. So symbol is going to hold a car and number is going to hold, I think these are all positive. So we'll call it a U32. I'm going to derive debug on this because I always derive debug when I'm working with stuff like this, even if I take it out later. And if we just check that this is a number, then this is going to be a number. So we'll expect on this 2-digit, which returns a result. We've got an interesting situation here. Make this a little bit smaller so that we can read the entire error message. So what we've got here is the closure might outlive the current function, but it borrows Y, which is owned by the current function. And that's because we're setting up closures inside here to handle these maps. And we are then taking those things and we are storing them. So like for here, we're storing symbol. So Y is borrowed here on line 18, right here. That's in our return value. So we're returning a tuple here. We haven't collected on this yet, so we should do that first. I'm going to collect into a B tree map of, what do we call these? U32s. I think I want these to be I32s. And the value is going to be a value. So that's our collect. We need to bring B tree map into scope. And then we'll have a different issue because we're trying to collect into something. So this is usize value. We could just make these usizes for now. That's totally fine. We aren't finishing up here, up top. So thinking about this, we're going to end up returning this here, right? We don't really want to collect this into a B tree map. This can still be an iterator, but if it's an iterator, we need a flat map. And then here we can collect into that B tree map. And here we've got some borrowing issues here. So we're back into closure may outlive the current function, but it borrows Y, which is owned by the current function. So this X character may outlive borrowed value Y. Y is borrowed on 24 now. So we're returning that value effectively in this iterator through this flat map into this value effectively. This closure here, if we look at line 38, is just used in this map. So the issue here is we aren't collecting. So what we're returning here is an iterator. And I can prove that to you if I do let t equals, and we hit the type inlays, we get impl iterator item equals usize value. So So this is definitely an iterator, 100%. And that means that the things that we're referencing, the things that we're iterating over, we're kind of like borrowing those. So we have options here. Rust tells us that we can make this move. So we could move like this, in which case the problem goes away. And that's totally fine. You know, Rust kind of gave us an answer. Let's do let map equals this. And this map is now a B-tree map, usize value. So if we debug the map here, we get all of these positions, which should amount to everything. We get a number here, we get empty there, and we get symbols here. So I think this is fine. We get our B-tree map of all of the positions in the grid and what exists there. Now, is this what we want? I think so. So how do we best answer the question? I think we could go through this and get the indices again, right? Like we could kind of group this all together and get XY values in groups. And then we can kind of look all the way around the outside of those values and see if there's anything there. The other way we could do this, I think that's the right way to do it, honestly, because we do need these numbers and we need to sum them. So we do need these at some point. And the best way to probably get those is to recreate them out of that index. So we could just make the really easy approach here, or the really basic approach of the map.entries, right? This will give us the key value pairs of this map, this B-tree map. And is entries not the right? I think it's just iter. So we've got this numbers vec of vecs that we haven't built out yet. And we've got an iterator over the map, which is going to give us XY values. So let's do print line with a debug formatter. And actually, we don't need the debug formatter. Print line with 2 display formatters. And we're just going to do X and Y. And we're going to do if let value number don't care equals value. Print line. And that gives us 0, 0, 0, 4. Where's our input here? 0, 0, 0, 4, 1, 0. So 0, 0 right here, right? And then 1, 2, 3, 4 is the 6. We want it in the other order. So we want it to be YX so that we can iterate over it and do this horizontally. So what we can actually do here is flip these. And then we get YX, right? And this is possible because B-tree map has a deterministic iteration order, like we talked about yesterday. So now we have 0, 0, 0, 1, 0, 2, 0, 5, 0, 6, 0, 7, and so on. So in my mind, I want to group these things together by some rule, but for the purposes of showing it, we're going to do a for loop. We're going to build into this numbers, I think. So if we have a number, we can take that now. Well, yeah, we don't really need it. What we want to do here is store the X values and the Y values so that we can get it out later. We actually probably don't even need to do that. We have the full map, which means we can access everything by XY position. So we kind of need that. Let's do this. And let's do, I think U32 was what I called it. So we'll do this with tuple here. We'll take num here and we'll do a match on numbers.iter.last. We'll fill match arms here. And this is either going to be a vec or it's not. If it's not a vec, then numbers.push a new vec with XY num. And this is a reference, so we'll dereference it. And these are probably also references. So we'll dereference those as well. So we're basically making copies to push into this numbers. That's totally fine with me. So if we don't have a vec, we push in. If we do have a vec, we need to check the last number in that vec. I can't think of another thing to call this V. So I'm just going to leave it there like that. This is the vec of our usize positions as well as the U32. We'll match on last num, fill match arms. This will be N, which is going to be the position and the number. So really what we need here is last num X. We don't care about the Y, we don't care about the number. And if last num X plus 1 is equal to X, right? That's what we're iterating over. Then we are going to want to push numbers.iterLoot.last.expect. This will exist. And this is going to be a mutable reference to this vec, at which point we push in X, Y, and num, all as values. So star, and star to dereference. Expected 1 field found 2. I didn't wrap this in enough parentheses to represent the tuple. And then expected usize found reference to usize. We're going to dereference this. So if that is equal, otherwise, we're going to push a new vec with the same contents. And in the none case, if there is no last number, that means we have an empty vec. I think this is a bad sign for us. So I'm going to leave unimplemented here. If we hit it, we know what we hit. But I'm going to leave in the full match here. So this for loop is getting pretty gnarly, in my opinion. I would have preferred to group, but I'll do that in a refactor later and show you the difference. So this is the loop. We should be able to debug numbers here. And this is going to look really awkward, but we're going to get 467. So 467. This looks wrong to me. The reason I've done it like this is to kind of show what happens if you don't build structs out. If you don't name things, if you don't build your own structs out, what you end up with when you debug is this mess of parentheses and brackets and stuff. So for some reason we are pushing in, oh right, because I reversed the order. This is not XY, this is YX. And you can't make that mistake if you use a struct here for X and Y, right? You can't mess up that order if to access X and Y, you need to say .X and .Y. There is a struct that we can use for this that already exists. I'll show you that later. So we've got 0, 0, 4, 1, 0, 6. So 4, 6, 7 in the first array. And then we should have 1, 1, 4, 1, 1, 4. That's correct. Then we have 35 and 6, 33. These all look good to me. So now what we have is map and numbers. Map is the entire grid and numbers is the sequential numbers. And what we need to do is we need to take the positions that we have for these numbers, build up all of the positions around them, check each of them for a symbol. If there is a symbol, that means the number is not a tool number. So we'll do numbers.iter. This gives us each vec of numbers. So if we do that in a for loop again, we can do like for numList equals numbers or for numList in numbers. We don't need to specify .iter here. It'll call into iter for us. But our numList is that vec of positions and numbers, which are all ordered for us. So what we can do here is basically build up all 9 positions. Woo. This would be easier if we had vecs, but we'll do it without and then I'll refactor. So we'll do let positions equals this, and this is going to be all of the positions around a single position for all 9 pieces. So if we're at this hash right here, right, we need to do y plus 1, y plus 1, x plus 1, x plus 1, x plus 1, y minus 1, and so on and so forth. So let's start with, and let's annotate this. So we're going to say this is x, y positions. This is going to be 1, 0. Bottom right is 1, negative 1. So in this case, what we end up with is 7 positions or 8 positions around the center point, and then let numList, or I guess for num in numList. No, I'm not going to do that. I'm going to do numList.iter.map. This is probably going to be a flat map. So then we've got position and value. We don't care about value here. So what we need is positions.iter.map. And it's going to be outer position. And this is going to be outer position.x. No, it's not .x because it's not a struct. Outer position.x, right? I guess it doesn't really matter. It works either way. But outer position.x plus position.x. And then outer position.y plus position.y. Leave a comment here so we know the ordering. So we've mapped over that. We've mapped over this. I think we can flat map here because this will give us all the outer positions. This will flat map that into a single list. Then we've got positions to check. And this should give us a list of unique positions. These are negatives because they're inferred to be U sizes because we're doing math on them like they are. What I'm going to do is position 1 as I32 instead. So we're going to cast our U size that we had earlier to an I32. And then this needs a type annotation. And that's just going to be vec I32, I32. And this should run and give us a list of positions. Let's just go check the first one. So this should be for 467. So we should in total have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positions, if I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 positions, 14 positions, 15 positions. Okay, so what I didn't do is I didn't filter out the positions originally. So this is unique, but what we still need to do is filter each num. NumList is that vec of U sizes, right? That's unfortunate. So let's do this to start with. We'll get num positions here, and here we'll do num positions, numList.iter.map. This is yx, and a value we don't care about. And we're going to make this xy because I think that's what we changed it to. And we'll collect, and we need to specify that this is a vec of I32, I32, because that's what we are going to compare it against, which means that we are going to need to cast these, which is fine for us right now. I think I need to dereference these. Let's check the error message first. Can't cast a reference to a U size as an I32. That makes total sense. This needs to be dereferenced, and then the squiggle goes away. Same thing here. And then down here, we do num positions dot, I always forget what this is called. I think it's contains num. This is giving us these 3 positions, which is exactly what we need, but we need this to be not contains num. So let's do pause to check dot length and pause to check debugged out next to each other, so it's easier and I don't have to count manually. So 12 is right. 12 is what we expected here. So we've got pause to check. Pause to check is XY. Always important to try to remember that. So we got 1, 0. That doesn't sound right. 1, -1. Let's do this. Let's do map. We won't debug that out. For each of the num lists, we have to do this. Pause to check .iter.any, pause, map.get. We did XY here, right? We need to do YX for the map. So I think it's this, map.get this. And this is just going to be the option value, match value. We can fill match arms. I guess we can do if let some value symbol, don't care which symbol, equals value, then true, else false. And this needs to be a reference to get from that map, I think. Unless I did something wrong here. What did I do wrong? Ah, yes, these need to be use sizes. Can we change these up here? It would be easier if we could change these. These are use sizes because we did 2-digit, right? So let's just make all of these I32s and then we'll deal with the consequences. We'll do as I32 here. And this is going to be an issue because flat map Y line, it's not the digit, it's the position that we need to swap. So it's here that we need to do the swap. So we'll make these I32s so we can deal with them. This is so much code. Okay, yada, yada, yada. Let is, what did we call these? Tool things or something? Part numbers. So is part number. So debug is part number and numList.iter.map tuple. We don't care about the position. We only care about the value, which is a num. We're going to num2 string this because I don't know how long the numbers are going to be. We're going to collect this into a string sillily. We're going to parse this into a number sillily. And hopefully I wrote that correctly. We're going to unwrap that because it always has to work. We'll let n equals that. Is part number n. Is part number false? 467. Is part number false? 114. I think I did the wrong way, didn't I? If this is a symbol, then this is a part number. These are not doing the right calculations because we're getting 3 trues. So let's print line this in a little bit of a better way. And then 35, 633, 617, 592. This is the wrong output. Let's see if we just flipped it. True, true. There's 2 falses. This is the right ordering. Again, not using a struct here, causing us some issues, causing us some pain. So even if we just had a struct with an X and a Y position, would have saved us a lot of pain here. So 114 and 58, are those the ones that we were supposed to find? 114 and 58, absolutely. We're in this random for loop, so let's mutate stuff. Why not? Let mute total equals 0, and then we'll do if is part number total plus equals this number that we're pulling out here. And then this is going to be total.toString. Need to update my thing here, but we have so many Clippy issues. Yada, yada, yada. Okay, so that's all well and good. Let's do cargo Clippy fix. I want to allow this, but I'm not going to in case it messes up. So I'm going to commit here. I'm going to do day 3 and cargo lock for some reason. And we're going to call this day 3 in progress. And then we're going to run cargo Clippy day 3 fix. So cargo Clippy fix should fix a bunch of that stuff for us. It won't fix everything. As you can see, we still have one of the things here, but we had a bunch of warnings. They were all Clippy warnings. And yeah, Clippy can just fix those for you in the most case. This is warning us that an if let else expression looks like a matches macro. That is absolutely true. The matches macro exists. But what I'm going to do is ignore that for now by using this allow Clippy matches like macro. And now it doesn't show up in the warnings and doesn't pollute our space, but we still know that this is something that we could fix if we want to. Okay, so tests are passing. Let's get the input. Significantly more input. Day 1, part 1. Oh, that's the wrong one to... Day 1, part 1 is not what we want. We want day 3, part 1. This is supposedly the answer, which I hope it is, because I don't fancy debugging that code. And that's it. That's the right answer, 1 gold star. So they found the missing part and installed it in the engine for part 2 as the engine springs to life, yada, yada. Maybe something's still wrong. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. The gear ratio is the result of multiplying those 2 numbers together. You need to find the gear ratio of every gear and add them all up so the engineer can figure out which gear needs to be replaced. So this is any star symbol that is adjacent to exactly 2 part numbers. So we need to kind of invert our check here. It's saying there are 2 gears in our test input, 467 and 35. Adding up the gear ratios gives us that. So let's get our part 1, copy this, paste it in here. Hope I can remember which piece of this code is the right one. For num list and numbers, that's not really what we want. We want not numbers, but symbols. So we're going to change all of this to say symbols. We no longer have a number here. All we're going to have is positions. So we take the numbers out. Each symbol can only be a single symbol. So I think we can get rid of this logic actually. We don't need 2 vex here anymore. We can only use, or we only need 1. We don't need this number. We only need the positions. So this is what we need to generate. Symbols.iter.last. Actually, we don't even need this. We can just filter for symbols. We do need those numbers though. So let's leave numbers here. Cool. Backed all that change out. And then for here, we don't need 4 num list and numbers. We need 4 symbol list in, or I guess 4 symbol in map.iter.filter key value, where value is a value. And we can use the matchers macro there. We get the positions. Symbol is going to be, we don't need to iter over num list because we already have the symbol position. The positions to check are going to be not iter. We're not going to need unique or filter. And this is going to be symbol.0.1 and symbol.0.0. These are the positions to check. This is not is part number. We need this to be is gear. So positions to check, filter map this. So when we do this get here, we can do is sum and we get a function here. And value matches value number underscore, because we don't care about it, or I guess X or whatever value. So we get the position out of the map. This is going to give us a value. We want that value to be sum, is sum, and this. We get the value. If the value matches, this is not a filter map at this point. And do something super weird, do then sum true. This actually doesn't give us what we need. We need to do the whole number check. It needs to be 2 different numbers. So I think what we need to do here is we already have the numbers, right? We have the numbers here and we have the positions of those numbers. So we've got all of these positions to check. We'll do indexes of numbers. We're going to move this down a little bit. Is gear. So we've got indexes of numbers. We've got positions to check. We've got the numbers. Let's do it that way. So this isn't going to be is gear. It's going to be for position in position to check is going to be a location. We'll do for num and numbers. I guess this is num list, right? We have a num list here, right? For symbol, no, we don't have a num list here. So let's do numbers.enumerate. That will give us the index and our num list. We'll do num list, iter, map. This is yx, if I remember correctly. Starting to lose track here. Let's start with xy. And then the value we don't care about. I'm going to back that out. I'm going to do find pause. If, let's do num pause and no value. Num pause equals pause is sum. Indexes of numbers, push I is going to be numbers that are enumerate. This is a reference and this is not a reference. So we'll make it a reference. So that should give us gear counts more or less. So let is gear equal indexes of numbers dot iter dot unique dot count is greater than, I think it's greater than or equal to 2. Let's check that really quick. A gear is any star symbol that is adjacent to exactly 2 part numbers. So this is equals 2. And then we do if is gear. First is in the top left, yada yada. How do we do the gear ratio? Multiply the 2 numbers together. So let's do indexes of numbers dot iter dot map index. All of this is coming in. This is going to be dot product. This is going to be num list index, which should always exist. So we're not even going to worry about it. I think we need to do numbers here. Yeah. So we do numbers, index, iter, map, yada yada. This is, let's work on part 2 here. This is a trait bound, not a trait bound, sorry, a generic argument. So we're going to do a U32 here, I guess. Is that what total is? Did we make total as U32? We made total whatever it wants to be. Cool. So total plus equals that. Attempt to multiply with overflow. So maybe we make this a U size and let's parse U sizes out. That's a really big number, right? What is our number supposed to be? Adding up all the gear ratios. Okay. All right. Adding up all the gear ratios. The gear ratios are these though, right? Oh, I didn't unique these. That's what it is, right? I uniqued these when yeah. Okay. We need to unique these because we need 1 of each number. This unique comes from iter tools, significantly lower this time. That's good. We're going to get a debug I here. And let's do a print line, empty string to separate it. We should get Well, we're debugging, so let's debug to push it out into the same chain here. Kind of want to make both of these print lines make a little bit less noise in the terminal. So 2, 2, 2, yada, yada, yada. Why are there 3 0 2s? That's this gear then. That's 0, 2. We do need that. We don't need it 3 times. We don't need 1, 3. Where was the most recent place that I did the XY thing? I feel like we need to unique the gears, which feels weird because we're only iterating over the symbols once. These are XY, which means that this is XY. Pause to check is XY. For position and pause to check, we've got the num list. The num list is the other way around, I believe. 0, 2, 4, 2, 4, 6. But why do we get 2, 0 there? This is looping for each symbol. All right, we swapped out matches. The order was wrong. There's one more matches that we did in here, right? All of the gear ratios need to add up to this, which is bigger than we have. 2 gears, is that correct? 1, 2, there should be 3. No, 1, 3, 4, 3, 8, 5. 1, 0, 1, 2, 3, 4 is this. 0, 1, 2, 3, 4, 1, 2, 3, then 8, 2, 3, 4, 5. These are all correct. 3 gears. We're supposed to discover this 8, 5 one as well, and we don't. Okay, so my ordering in the XY was wrong. Again, the reason I didn't use a struct with XY here is to address some comments in the last video that said they would like to see things done in a little bit more of a primitive way. This is what happens when you don't use structs with named fields. So let's run part 2 here and hope that that's the answer. And it is. Yay, gold star. But honestly, this is kind of a wreck. Let's do our benchmarking anyway. Let's get all of our print lines out before we do any kind of benchmarking. Okay, so Devon's saying that this takes about 2 milliseconds for part 1 and 10 for part 2. We've got approximately the same from Criterion. So we've got 2.8 compared to 2.5 and 11.5 compared to 10.6. I think that for me is within margin of error. But this is like the slowest solution we've done so far with these for loops. Just for kicks, let's do the DAT profile as well. So for part 1, we use the most memory we've used out of any approach so far. And for part 2, it goes down a little bit, but not by much. So I think that's like 2 megabytes and 3 megabytes, if I'm reading that correctly. It's 1 million bytes and 3 million bytes. So since these run for so long, we might be able to get something a little bit better out of our flame graphs. Not really. So we've got hash brown here, vec, process, main. Not super interesting in terms of flame graph. I am going to make sure that I have everything set up correctly for the flame graphs tonight. So we'll see. But yeah, overall, this is super messy. So instead of doing a deep dive into what we did here, I would like to talk a little bit about what I would improve and how I would do this differently now that we've solved it. So the first thing for me is there are probably better tools to use here. The very first tool that comes to mind is, of course, Glam, and it has an IVEC2 type that is just an X and a Y. And this is a wonderful library. It underpins Bevy. It's SIMD accelerated for all the math. So this would help us out so much, honestly. Like anywhere we have an X and a Y, anywhere we do this little thing with the tuples, we would have an IVEC2, and an IVEC2 has .x and .y. So we never need to remember which of these U sizes is which. We always know which one is X and which one is Y. This would also help us out when we're doing this huge position buildup, because each of these can be an IVEC2 itself, which means that when we do this positions iter, we can just do outer position plus position and it'll just work. We don't have to like remember which one is X, which one is Y. And this doesn't become a tuple anymore. All of this logic becomes much more direct, more exact. The other thing is that this for loop is probably better executed as a fold. There are possible tools and iter tools that could potentially help us build up better versions of this, like multi-peak, which would allow us to look forward multiple times to find all the numbers. There's also things like take while inclusive, right? So we do items, into iter, take while inclusive, whatever, and it'll just pull stuff off the front. In this case, we use take while to pull a couple of items off of this array. Those items get pulled out into this result here, and then iter is used again, and when it's collected, those items are gone. So we could definitely use this to kind of build up the numbers and the positions for those numbers without having to do this whole like vec push manual thing. One of the things I really want to convey here is that what we're doing here is very manual. It's very, we build up, we check. We are not using indices, we're using dot last because indices would have made this even worse. But we can get rid of a lot of this manual management of resources by taking advantage of some of these other tools. In this example, sort of skip while is used to skip this first negative number, after which you can continue to iterate and then find, maybe another one and skip it again. So I think what I'm going to do is I'm going to take this offline. I'm going to stop recording. I'm going to potentially refactor these. I'm going to commit this as it is, and then I'll do a deep dive after I refactor.